In this first demo, we show IoTeX's Strive code being run on a variety of lightweight IoT devices. The devices we used are a Raspberry Pi, which is an ARMS-based single-board device, Vocore 2 wireless router, which is a coin-sized Linux device running a MIPS architecture, and a Pocket Beagle, another small coin-sized Linux device running an ARMS-based architecture. To test Strive, we cross-compiled and implemented the IoTeX core code, which is programmed in Golang, onto each of the devices and tested two separate configurations. For our first test configuration, we run a Raspberry Pi as the delegate node and a Pocket Beagle as a full node, connected via USB port to emulate a TCP/IP network between the two devices. First, we start the delegate node on Raspberry Pi. You can think of it as a server, and it will generate blocks every second. Next, we remotely log into the Pocket Beagle and run it as a full node, meaning it will receive the block data produced by the delegate Raspberry Pi and store it to its local blockchain. For the second test configuration, we run the delegate node on the Vocore 2 wireless router and the full node on the Raspberry Pi. These two devices are connected via Wi-Fi to emulate a wireless network between the two devices. First, we start the delegate on the Vocore 2 device. As you can see, the Vocore 2 delegate node has started producing blocks. And now, the Raspberry Pi, operating as a full node, receives and stores the blocks sent out by the Vocore 2 delegate. In this first demo, we showed for the first time the IoTeX blockchain running on lightweight IoT devices with reasonably low computation and memory resources. For reference, the Golang binary size is roughly 80 megabytes and consumes about 60 megabytes of RAM. We are actively working on reducing the footprint size and improving performance to make the IoTeX blockchain even more resilient on lightweight IoT devices.